Okay, welcome back to my channel. I thought I'd give a little update on the progress of the redesign for the t-shirt cannon. The general thought behind what I've done so far is more or less, what could you do if you had CNC machining pretty much everything, which with one of our newer sponsors we might just have access to all of that. So with that idea in mind, I basically turned a fairly simple block from previous into a pretty complex piece to be milled via CNC, and a lot of internal geometry, a lot of pocketing, a lot of internal gearing and whatnot, bearing housings. This is a lot more representative of what an actual industrial gearbox looks like. We have a lot of stuff at work at Drake that looks a lot like this. A lot of things carved out. Everything's purpose built, purpose cut into the material. As you can see, front and back bearing housings for a set of angular contact bearings. I'll get back to those in a minute. I have the area for the rotation, the angle, trajectory, pivot shaft bored out through the middle block, including pockets for Versa hubs on both sides. I don't have the whole patterns in there yet. I'm still working on a lot of the details and whatnot. I have a cutout for the for the Versa Planetary. This is set up for a 2-stage currently, as I'll show in a minute, of course. Since the radiuses were so small on the Versa Planetary, and I didn't think you could get a mill that deep with such small radii, I added undercuts to each of the sides. So if we get the fit right on the inside of this, this should fully support the entire body of the Versa Planetary. And of course there are through holes all the way from here to the other side, counterboard to hold the Versa Planetary. There's a through hole for the shaft. This is an interesting little pocket. This is for access to be machined, a bearing pocket in this side, and of course this side. But I also need this area which holds the bearing to be fully supported. So what I end up doing here in the full model is turn some of this stuff off real quick, is adding a filler plate with some countersunk screws, so it creates almost a zero fit when it's done. So when they come back to bore this bearing out, they can bore both pieces as one part, so it fits normally. Covers up that bearing hole and still gives you access to press bearings into both those sides. So if I get rid of this cover, which is sheet metal, which we're not sure if we have a sponsor for, but I'm sure we can find something to cover that with, possibly thin Lexan, just bent around it just to cover up this. This is a 3-to-1 gear set. Currently this Versa Planetary with this giant honking sim motor on it is set up for 2-stage 100-to-1. This gearing probably won't change, so this is the only gearing I could fit between the Versa Planetary shaft and the output shaft. It's the only gearing I could fit. It even has to reverse a little because the bearings are so large, and again I'll get to those in a minute. But yeah, pinion, reversing gear, and then the output gear. Total 3-to-1. compared to what's in here. Again, this is reconfigurable in many ways. That's pretty much it for the drive, I think. I mean, again, this can be reconfigured. RS motors, bag motor, mini sim. You have your air fitting and hose just like it was on the previous model. The rest of the drive is, let's unhide some stuff here. The rest of the drive, trying to find what I'm looking for. Let's see. And there we go. Cutaway. The rest of the drive is based on this central shaft, 1-inch hex, just as it was previously. Hex bore cut into the large drive gear. A hex bore driven into this. This is an 8-lobed cam, if you will. And just like the 2014 robot, it uses the same principle. This lobed cam actually rotates with the shaft, of course. It's hex keyed. And you can see kind of from the side, we're actually jamming a pin with ball bearings in it. Basically a roller across the top of the cam, and when we index, we use a pneumatic cylinder to jam that into place and actually lock this cylinder and all the barrels into one of 8 positions for firing. Makes sense. This 1-inch hex shaft is tapped or threaded on both ends for nuts. There is washers, spacer, the main barrel assembly. There are bushings in here to adapt the hex to the radial angular contact bearings. All the way through to the other side, there's another set, or there's another bearing, another flange with hex in it, a washer, and another nut. And the idea behind this is, as you look at this model, and the reason I picked this is the distribution of forces. Basically, this is how it should be designed. I'm not saying we're actually going to buy these components. They can be costly, but this is just kind of my interpretation of it. But basically, the principle behind this setup is you have the 2 nuts at either end. You tighten those down, you add tension to the central drive shaft. The tension in that shaft is taken up by the spacer into the drive housing, into the first bushing, all the way back to the other nut, which is on another washer, another drive bushing, and into this bearing. And what happens is you get a tension force between the 2 bearings, and you actually get an axial stiffness, if you will, in the load. So any moment or any torque introduced by the barrel, the weight of the barrel sticking out to the end, is actually picked up better by these bearings. If you compress these bearings properly, you can imagine a line of contact from this corner of the ball bearing down to this corner of the ball bearing, and that line of contact is radially pointing at a point further out on the shaft. Any point along that line and your forces are 0, meaning you pick up a lot more moment and all your forces are directed into the bearings. It makes your drive shaft quite a bit stiffer. So that was just a kind of a thing I picked up from work in proper design of bearings. that this is going to take a little bit more of the axial load. It's going to be a little easier to drive the whole system. You're not going to have as many losses compared to the needle bearings that were in there before that could only take the radial forces. And again, these are in a set, they're opposing each other, so the forces on this one are going to go out to this end, and the forces on this one are going to go out to this end, making the whole system stiffer. I think the last thing, and this is kind of a pipe dream because this thing is expensive. Of course, it doesn't have to be. This could be, theoretically, this could be a standard incremental encoder if we assume that this locking into position gives us a home that we can zero off of upon startup. But there's also the option, and it's the same housing, same bolt pattern, that this is an incremental or absolute encoder that actually has memory. It tells how many, it knows, has 360 counts, so it knows each degree around the circle, and it knows how many rotations it's been. I'm no electrical engineer. I don't know how it does it per se. It is an optical encoder, so I know how that works. But yeah, that's one or the other. I'm sure we could get the logic to work with the lockdown mechanism. But yeah, I got a lot of details to figure out still. Porting a shaft for this, putting a set screw in to hold the encoder shaft in place. I'm gonna figure out what to do with the end of this yet. There's gonna be bearings in here, well, between the gear that sits over here, these two holes that you can kind of see in the silhouette. I don't know, there's just a lot of little details that I can fill out, but I'm kind of working on the overall larger concept for right now. That's pretty much it as far as showing this off so far. Progress so far. I'm going to keep working on it, figuring out little things as I go along. And again, this is not just my project, this is the team's project, but you know, things are open for debate, things are open for change. If anyone has suggestions, contact me by email. You should know it. If you're part of the team, of course. If you're random internet scab, you can leave a comment. I don't care. I'll get back to it if need be. But yeah, this is my little tinkering project now that we have a machining sponsor. Well, that's pretty much it. I will see you guys later. Oh, I might start recording progress as I go. I may not be able to talk the whole time. I'm not a YouTuber. I'm not talented like that to just BS my way through a 15-minute video. But I'll try to see what I can do to post kind of live updates as I do this throughout the off season. Anyway, that's pretty much it. Good night.